Continuing on with our rules of exponents, with a situation where we have a power to a power. We know that exponent means, right, how many times you use the base as a factor. So here for x squared, I've got it's x to the first times x to the first. And we reviewed that when we're multiplying like bases, we can add the exponents. This situation is slightly different, because here the base is not just 2, the base here is really 2 to the third. And this exponent of 2 is saying we have 2 of those 2 to the thirds. So in actuality, this is representing 2 to the third times 2 to the third, this multiplication. And if it was written like this, we would very quickly say that this is going to be 2 to the sixth. If it's written like this, sometimes we get confused and say 2 to the fifth, but it's not. This is telling me that we have 2 groups of these 2 to the third powers. And so 2 groups of 2 to the third means I can multiply 2 times 3 to get 2 to the sixth. So the rule, the exponent rule, is if you have a to the m to the n, so this is already a power raised to another power, you can multiply those exponents and write it as a to the mn. Right? So power to a power we can multiply, which is different than multiplying. You can combine or total the exponents. So this is a power to a power. X to the fourth to the third becomes x to the 12th. It's 3 groups of x to the fourth. X to the fourth times x to the fourth times x to the fourth will be x to the 12th. Now, if we have a coefficient, right, now the base is the whole thing, 2x to the third. So coefficient of 2, x to the third, all of that is the base to the third power. So if we wrote it out, it would be 2x to the third times 2x to the third times 2x to the third. So what happens if you use commutative is you see that you have 1, 2, 3 powers of 2. 1, 2, 3 powers of 2. And we've got 3x to the thirds. So it's almost as if it's 2 to the third and x to the third to the third. Both of these factors, 2 and x to the third, both get raised to the third power, so it becomes 8x to the ninth would be our answer. Now, the more basic thinking math student says, oh, I distribute the third power. It's not really distributive property, so I don't want us to, that's a poor vocabulary word for this situation. I want us to think of it as power to a power, so each factor gets raised to that exponent. Each factor gets raised to that exponent. And order of operations follows. So the first thing I would do is take care of this. Can I do anything in the parentheses? No. Anything in these parentheses, I can't simplify that, but I now can do this exponent. And so the first thing to do would be to simplify this part because it has an exponent before then I multiply it through. So the 2x I would bring down. This parentheses now becomes 4 to the second, x to the second to the second, or x to the fourth, and y to the third. So 16 x to the fourth and y to the second. And then 3x squared y to the fourth. And now it's all multiplication. So now I've got 2 times x times 16 times x to the fourth times y to the second times 3 times x squared times y to the fourth. And multiply them in whatever order I want. Commutative property, I would multiply the coefficients first. And 6 times 16 is 96. X times x to the fourth times x to the second is x to the seventh. And oh boy. There you go, buddy. And the y's, if we look at the y's here, we've got y to the second times y to the fourth is y to the sixth. Ooh. You know what I think about this? Fun. Alright, so order of operations, parentheses first. I got to make this. Now this squared is only not controlling this 2, it's only controlling the x to the third. So I'm thinking of it as 2x to the sixth now to the second. And now this exponent of 2 is controlling, this exponent of 2 is controlling the parentheses. So everything in the parentheses, each factor in the parentheses needs to get so it becomes 4 x to the 6th to the second, or 4x to the 12th. Alright, I'm going to give you a chance to work on this one. This is a little kind of complicated. We've got parentheses, but we've got to take care of each of the exponents first and then multiply across. Alright, do this one and come back in a second. Thank you. Okay, so if I take care of all the exponents first, everything here gets raised to the third power. So 2 to the third is 8, x to the third is x to the third, y to the second to the third power to a power is y to the sixth. Everything in this exponent, in this parentheses, gets raised to the third power. So negative 2 to the third. What about the negative? How many negatives are there? There's actually 3 here. So the answer is negative. 2 to the third is 8. Y to the second to the third is y to the sixth. And everything in this parentheses in blue is squared. 5 squared is 25. X to the fourth to the second is x to the eighth. Y to the second is y to the fourth. Now this is all multiplication. So I'm multiplying the coefficients and I'm adding the exponents. And 8 times 8 times 25, 64 times 25 is 1600. And there's only one negative factor here now. So negative 1600, x to the 11th, y to the 16th. Alright, this is from last time. Alright, what I wanted to do was skip down to this part, because we had here power to a power. So one way to think of this particular expression is 25 to the 3 halves. I'm not sure that that gives us any closer to an answer. So a second option would be to take this one and change this to 25 to the 1 half is 5. So change it to 5 to the third, and then you can evaluate it as 125. What if it's a fraction here? This one I'm going to change to, I'm going to kind of pull this one apart. And so 5/4 is the same as 5 times 1/4, or 1/4 times 5. Either of these is 5/4. So I'm going to write this as 16 to the 1/4 to the 5th. Because 16 to the 1/4, I have another name for it. The 4th power of 16 is 2, so this becomes 2 to the 5th, which is 32 is the answer. So 16 to the 5/4 is 32. Alright. Okay, see if you can do this one. So what would 16 to the negative 5/4 be? Well, negative exponent means what? That's right, reciprocal. So if 16 to the 5/4 was 32, 16 to the negative 5/4 should be 1 over 32. Alright, we're going to do some practice with these different exponent rules. Again, we're following the order of operations. You got to realize, what situation do you have? Are you multiplying like bases, in which case you add the exponents? Are you dividing like bases, where you subtract the exponents? Do you have a power to a power situation? Or do you have a negative exponent or a fractional exponent? Got you in under 10 minutes. Namaste.